Hello, grade 11s. It's still our Triple M day, which is Mindset is Maths Monday. Hope you're all relaxed and ready to learn a lot. My name is Abraham, and I'm not alone. I'm with Dina. How are you, Dina?
Hello, Abraham. I'm very, very well. And how's everybody out there?
They are pashash. They are number one, I'm sure. Because they couldn't wait for this show. I've been seeing on our Facebook page saying, you know what, let's go. Grade 11s, we're up and ready. But for today, what are we doing?
Abraham, today we are going to look at some of the work that we've already covered in Term 1. So we're doing some revision. We're looking at some equations, some inequalities, and some nature of roots. So we're going to do a couple of examples to see how much you can remember from Term 1.
Jam-packed show, I tell you right now. Let's get ready. Dina, take your position.
Thank you.
Right, Mindset is talking about being ready. It is our Triple M day, which is Mindset is Maths Monday. And also, there are 3 things that you need to know. One is that you can chat with me over Facebook. Send us your comments and also your questions. Our Facebook link is facebook.com/learnextra. Get your friends also to like the page because currently we are at 41,000 and more. If you still want to be part of this family and let the family grow, tell other people so that they could also tell other people. We are running also a competition on our Facebook page whereby you can just guess when do you think we can hit 42,000. If you know the answer, you're good at guessing, go over our Facebook page. And number 2, you can also tweet us at LearnExtra. And lastly, this show is proudly sponsored by Macmillan, and the notes that you can download today for free can be accessible on learnextra.co.za/live, or the link, I'll make sure that it's posted on our Facebook page. But for now, let the learning roll. Dina, take it away.
Thanks very much, Abraham. Grade 11s, are you ready to see how much you can remember? Because if you can remember all of today's work, then you are certainly ready for your June examination and maybe even for that final examination in November. So let's get right to it. The topics for today, we're going to look at some equations, some inequalities, and both those in the quadratic field. We're going to look at the nature of roots, and we're also going to look at some work around exponents. We're going to revise those 4 topics by working through some worked examples. And the first section will be quadratic equations and inequalities. We're going to solve for x in each one of these. And before we actually get there, I would like to look at what is the quadratic formula. It will be in your formula sheet. But just to remind everybody, the quadratic formula is, for a quadratic equation, is minus b plus or minus the square root of b squared minus 4ac, and we're dividing everything by 2a. So if we're solving a quadratic equation, we would like to use the formula if the factors aren't readily available. Okay. Now, I've grouped these together so we can start discussing some of the trends that we see. So the first thing that you need to look at is always to read the instruction. It says solve for x. And the first one is where x squared is equal to x. Second one, where x squared is smaller than x, where x squared is bigger than x, and then 3 times the bracket is equal to negative 7x. Now, when we look at the grouping, I would really like to concentrate on how we would solve these 3, because they really are together. We're going to really try and dig and probe into what method of solution we're going to employ and also how we would go about it. Now, grade 11s, I find that when the equation x squared is equal to x, very simply written, it's an x to the power of 2, x to the power of 1, and a number of students, even at grade 10 level, because you really start with quadratics at grade 10, will say, well, if I've got x squared is equal to x, then I can divide by x on both sides. So I'm getting that x must be equal to 1. Okay, now if we go back to the original, we then find that if x is 1, it makes that a true statement. But when you're solving an equation, you want to make sure that you have found all the possible values of x that that equation could have so that that statement is true. So you're trying to find every single one. Now you found one value, and the interesting thing about a quadratic equation is that the highest power tells you what the possible number of solutions are. So if you've got the highest power as 2, you should be able to have a maximum of 2 solutions. we've only got 1. Now that is not cause for concern, because sometimes quadratic equations do only have 1. But we must be certain that we have the conditions, the right conditions, to be able to give us 1. And so I want to look at 2 things. What kind of quadratics will give us 1 solution? So that if we know what that model looks like, we can try and see if we can apply it to this case also. And the kind of quadratics, we're going to pause here, we're going to camp here for a little while, just pause there. We're going to say, what kind of quadratic equations have 1 solution? With 1 solution. And you may also ask, well, what kind of quadratic equations have no solutions? Okay? So quadratic equations with 1 solution is anything that has got a bracket squared. So if you had x minus 1 squared, for example, then x could only be 1, because 1 minus 1 is 0. Or you could get an x squared equals 0, for example. So any quadratic equation, when it's equated to 0 in its squared form, its perfect square is going to give us only 1 solution. Now if you compare that to this one, x squared is equal to x is not equal to 0 at this stage. So we don't have a perfect square. So I'm at this stage arguing that I'm dubious whether this equation only has 1 solution. Okay. So grade 11s, you find that many people will try and automatically divide by x. We get 1 solution, which is true, but my question is, are we missing another solution? And the problem is we are dividing by this unknown. And this is what's creating a loss of a solution. Because we don't know what its value is, okay, remember, we don't know what x stands for. So x could be 1, x could be 2, x could be 3, or whatever. If x is 0, then you're actually dividing by 0, and you're creating an undefined left-hand side, and you're creating an undefined on the right-hand side. So the golden rule in mathematics is that you cannot divide by an unknown, otherwise you are going to be losing a solution. So with any quadratic, we need to just always be that little bit more cautious. And when we start solving a quadratic, we would always say, let's start off by not dividing by 0, but preventing that division by 0, but actually equating to 0. So the first thing would be to equate to 0. Because it's only when it's equated to 0 that we can apply the quadratic formula, number 1. But secondly, we can also now see that there's actually a common bracket. So there's a factor x, and there's a factor x minus 1. That could be 0. So we're actually saying that x could be 0, or x could be equal to 1. Notice we got this one earlier, but do you see that division by x has actually prevented us from getting the second equation? So a division by an unknown will give us half of the answer, will give us x equals 1. Now we know that in this equation, x can both be 1, because 1 squared is 1, and 0 squared is 0. So x could both be 1, or it could be 0. But if you are going to divide by 0, if you're going to divide by x, or a division by an unknown, we're only getting half the set of solutions. We've lost a set of solutions. And the other thing you're doing is that maybe in the other set, there could be a value for this unknown, which is actually 0. And now you're dividing by 0, which is actually creating an undefined statement. So there are 2 problems with a division by 0, with a division by an unknown. Firstly, you only get half the set of solutions. And secondly, you're actually dividing by a value that you're not allowed to divide by. So we have a golden rule in mathematics. You do not divide by an unknown, because you're going to create this cascade of problems, the loss of a solution, only getting a half of the set of solutions, and then also dividing by this number that is going to create this undefined statement both left and right. So to avoid that, we would always equate to 0. We would then get it into linear factors. So we go from the quadratic and we would make it into linear factors. In other words, we would factorize. Now, at this stage here, when you've got this x factorized, you could still be tempted to be dividing by x on both sides. But that is if you really have thought about and have taken in that understanding of an unknown in an equation, you will always stop yourself and say, I cannot divide by this unknown. It's going to create a whole lot of problems for me. So we would not divide, and here we would get both the solutions, x is 0 and x equals 1, because at the outset my quadratic was not a perfect square, so therefore it doesn't only have one solution. Now, this is the first problem that grade 11s encounter, is that division by an unknown. So we want to avoid that. The second one is, what happens if we now would like to find out where is x squared smaller than x? So we're saying find a number so that when you square it, it's going to be smaller than the number you thought about. Well, can you think of such numbers? Take a number, for example, 4. If you square it, you get 16, so it's bigger. So what number should we be choosing so that the values, the squared values, are smaller than what you started off with? Okay, now again with that, with the inequality, it's not equivalent to say that we are going to divide by x. We've already spoken about that and the problems that it creates mathematically. So we're now going to say, let's do the same thing. Let's take x squared minus x. And let's get a 0 on our right-hand side. So for anything quadratic, we always have that 0. And now let's just work with this side. We've now got factors x into x minus 1. Now, grade 11s, there are a number of ways of working with this. Some of you may, at school, work with a number line, and your teachers asked you to work out the signs between each of the critical values. Some of you may use a table method. I like to connect my algebra to my quadratic function. So I always ask my students to draw what they see algebraically. So what we see algebraically is the product of two factors. And the product of two factors is always a parabola. And the zeros for this quadratic would be at 0 and at 1. And what we're now saying is, please find me all the x's where the product is going to be less than 0. So we now go to the parabola and we say, well, these are all the products. The parabola's got products that are negative between 0 and 1. So we're saying that between 0 and 1, so for example, a half, if I take a half and I square a half, I get a quarter. Ah, a quarter is smaller than a half. So the values between 0 and 1 will be the only ones that will satisfy that inequality. Now the next one was, where do you think it will be greater than? So where would you take a value and it's greater than? Well, in that case, if we wanted to find out where is x squared greater than x, it's obviously not going to be in the blue region, but it's going to be in the pink region. So if anything's bigger than 1, we saw earlier that when we took 4 and we squared it, that 16 was bigger than 4. So if we take any of these values bigger than 1, and we take values smaller than 0, so there's a set of points, the blue set, that will make that statement true. There is the pink set, so where x is smaller than 0, or x is bigger than 1, that set will make the inequality, the x squared, bigger than x. Okay, so the inequalities, when you're trying to solve an inequality, you would still get a 0 on the right-hand side. You would then always get factors. Your factors, when you plot them, would give you a quadratic. Now, this would only work if you had a quadratic, because the moment you have a cubic, you need to be able to draw a cubic. And so sometimes for example, in grade 12, if you did have an inequality with a cubic, it would be fine, because you'll be able to then sketch a graph by that stage. But for now, your critical values would only work if you had the parabola. And it's really nice to understand how the product of two brackets, or the product of two factors, is each of the y values. That on a parabola, each point, each y value is made up of the product of two numbers. And so we are integrating, we are interconnecting what that algebra actually represents pictorially. And can you see how when there's a picture, it kind of helps us to think of the numbers between 0 and 1 and to say, yeah, I can see that those numbers are the only ones where you would square it and you would square x and you'd actually get it that it would be smaller than the actual value chosen. So that is just a little bit on inequalities. Equate to 0, draw your critical values, and then extract the values. What we don't want you to do is to say x must be smaller than 0, x must be greater than 0, or x must be greater than 1. You do not take that inequality and just map it onto two sets of values. And I think on that note, I'm going to send you back to Abraham.
Thank you very much, Dina. You know what mindsetters are saying? We shouldn't even have a break. That's Msova says, Dina, take it away without any break today. But then also she says, hello to you, Dina. We've been waiting for you for such a long time now just to say hi. Hello. Right.
Yeah.
Thank you very much, Mindsetters. On the page, I can see that you also like the Triple M, which is Mindsetters Maths Monday. Keep it rolling and let's keep on learning. See you after the break. Welcome back, grade 11s. I hope you're still tuned in and learning a lot on this wonderful show that we're having with Dina. And now it is that time where I tell you and remind you that you can also take your part by taking your time and downloading our notes on learnextra.co.za/live. Also have the fast link on the Facebook page, which is facebook.com/learnextra. Make sure that you jump over the page and see what our other mindsets are saying. If you've got any questions, feel free to post them in and we'll help you. Dina, that's how we roll. Number one.
Thanks, Abraham. We are with you to really help you, and I'm hoping that some of you have downloaded that material because then you can get a head start, and now that I work through it with you, it will seem so much easier. So I really do want you to get onto those pages and really download the material so that it can be much quicker for us. Time just flies here when we're having fun with some grade 11 mathematics. Right, we're on to nature of roots, and for those of you who have already covered that material, it is really understanding what kind of solutions a quadratic equation has. And we noticed that with really trying to come up with something that tells us what kind of roots we're getting, we found that there's a special expression that deals with that, and that is the expression in the quadratic formula that sits underneath the square root. So I'm not going to go through how we develop that. I'm just going to give you the breakdown again to just remind you, and then we're going to go into some questions around the nature of roots. Okay, so that very famous expression is called the discriminant, and the discriminant is b squared minus 4ac. And in its symbolic form, we just call that delta. Okay? And a, b, and c are going to be the rational numbers from the quadratic. Then delta will determine the nature of roots of the quadratic equation. And then we've got these four cases. If delta is a negative value, then the roots will be non-real. Remember earlier, we were talking about how many roots or how many solutions does a quadratic have. And if the quadratic has no solutions, then it means that b squared minus 4ac turns out to be a negative number. Then the very famous, if delta is equal to 0, then the roots will be equal. In other words, that's the time that we've got one root. So we've got one rational root. You can also write that down. When does that happen? That happens when your quadratic is a perfect square. Remember in the first section, we looked at when does a quadratic have one root, one solution. When your quadratic is actually a perfect square. And that happens when delta is also 0. Then we've got two cases. We have the case where delta is positive, but also a perfect square. And then we have the case where we have delta is positive, but not a perfect square. So if it's a perfect square, then we're going to have that the roots will be rational. But in this case, they will be unequal, because you only have one time that they will be rational, and that is, or they are equal, and that's when delta is equal to 0. And then we have when it's not a perfect square, then they will be irrational and also unequal. So we've got one time that they are equal, we've got twice that they are unequal. And obviously if they're non-real, they will also be unequal. But if we've got the two unequal cases, one case will be rational and the other case will be irrational. So we're going to use this table to just remind us of what we need to use with delta when working with the following questions. Okay, so it says, without solving the equation, so here's an equation. Let's talk to ourselves. What kind of an equation is it? 10 minus 9x plus 2x squared equals 0. The highest exponent is 2, so it's a quadratic, because we won't look at the nature of the roots of a cubic, for example, even a linear. What's really interesting is the nature of roots of a quadratic. So we first recognize that it's a quadratic, determine the nature of its roots. Now we could solve for that equation and then determine what kind of roots it's got, but they say without solving. So what is that prompting us to do? If we aren't going to solve the equation, what else will tell us how we can find the nature of the roots? Okay, and we said earlier that the nature of the roots comes from b squared minus 4ac. So we now need to go and find this value, this b, this a, and the c. Where are we going to find b, a, c? How are we going to find them? Well, yes, you're right, we're going to find them in the quadratic equation, but remember that a, b, and c are specific numbers. It's not a comes first and b comes second and c comes third. They represent coefficients and constants. So my really safe option here is to just rewrite this as 2x squared minus 9x plus 10, because in that way, a is always the coefficient of x squared, b is always the coefficient of x, and c is always the constant. So a in this case is 2, b in this case is minus 9, and c is 10. And you can see how we actually have, we're not tempted to say that a is 10 and b is minus 9 and c is 2, because it doesn't come from a, b, c, 1, 2, 3. It comes from the coefficient of x squared. So grade 11 is very important to order your equation x squared, x term, constant. Now I can go and find out what a, b, c is. All right, so let's go down and just write that equation down again. So it's 2x squared minus 9x plus 10 equals 0. And have your a written in front of you. It's 2, b is minus 9, and c is 10. Just see if that was the given one. Plus 10, yes. Now, first thing you do is write down the formula. Delta is b squared minus 4ac. And now you can substitute. So b is minus 9, a is 2, and c is 10. And carrying on, that would be 81 minus 80. So we get 9. Okay. Now, our nature of the roots is going to come from into which category does that delta fall in? Okay. Is it negative? No. Is it naught? No. Is it positive? Yes. But which positive is it? It's 9, which makes it a perfect square. So it puts it into that category. So out of the 4 categories, we're going to find one that it goes into. So it's a perfect square. Then the roots are real, rational, and equal. And once we've got it in its category, we are able to see what the roots are. So let's go down and say, since delta is positive and a perfect square, the roots of the equation are rational and unequal. Okay, so we're able to say what kind of numbers we're going to get as our roots. We're going to get them as rational, and they're going to be 2, and they're going to be different. Okay, so that's how we would answer that one. Now, let's just erase this. It's sitting a bit in the way here. Okay, next one. For which values of k will this equation have equal roots? Okay, well, let's read it again. We've got to find we've got to find k, for which values of k. Will the equation, here's my equation, what kind is it? Excellent, it's quadratic, highest power is 2. When will it have equal roots? Can you see they are telling me that this equation must obey that instruction. It must have equal roots. So in this case, we're not looking at the categories. We're going up to the categories and we're saying, which one gives us equal roots? Can you see it's this one that gives us equal roots? So we can come back and say, that means they're telling me that delta is equal to 0. So for this equation, x squared minus 6x plus k is equal to 0, we are given that it must have equal roots. Equation must have equal roots. Well, when does that happen? Therefore, we found that that happens when delta is equal to 0. So sometimes we will know what the delta is that's given, so we can make an interpretation. We can make an equation out of it. Other times, we've got to go and find in which category that those roots are in. Okay, so again, delta, straightforward. It's b squared minus 4ac. It's always the same thing. It doesn't change. Is equal to 0. B is negative 6 squared. A is 1 coefficient of x squared. C is k, and that's equal to 0. And so we get 36 is equal to 4k. So k must be equal to 9. So when k is equal to 9. So if we go back up and we see, okay, what are they telling me? That if this equation is to have equal roots, do you agree? It means that the equation would have one root. And we said earlier, an equation has one root if the whole quadratic can be factorized as a perfect square. So let's go back and test it. What we've just found, what we're just saying to ourselves, is that this is the equation that will give us equal roots. Why is that? Because the root will be x minus 3. The root will be x equals 3. Now there are two brackets, x equals x minus 3 times x minus 3. So x equals 3. But it's the same value. It's being repeated. So that's why we're saying they're equal. There are two of them. There will always be two of them, but they are the same. So they're not distinct, so we call them equal. So there's actually only one root. And remember, that will only happen when the quadratic can be factorized into a perfect square. So we're actually connecting the knowledge of what equal roots are, or the knowledge of what delta is doing when we have equal roots, to the fact that we can connect it to our original statement, which is actually talking about what kind of quadratics we actually get. So we can get quadratics that can be factorized into two rational roots. But in this case, it can only be factorized into one. Let's see what the next question is. Determine the values of p if the equation, if means it's the given. So we want to find out what p is. If this equation has real roots. When do we get real roots? Well, let's go back up and look in the box and see where do we get real roots. Well, this pink one is giving me non-real, which means green, orange, and blue, they all give me real roots because rationals and irrational numbers are all real numbers. So do you agree for my equation to show me real roots, I can have any of these except the pink? So I can have a delta that is positive or a delta that's equal to 0. So we're going to connect those and make them 1. Let's just see. It's 2x squared minus 4x plus p. 2x squared minus 4x plus p equals 0. Okay, that's the quadratic. Write down the given. Every time something is given, let's put it down so we don't begin to think that we're imagining things. So the given is that the equation, and let's write it in English, equation must have real roots. We've gone to our box of discriminants, and we have found that the only time that it's non-real is when delta is negative. Therefore, we want a delta that is greater than or equal to 0. So delta is b squared, which makes it minus 4, all squared, minus 4ac must be greater than or equal to 0. which means that 16 minus 8p must be greater than or equal to 0. So 16 must be greater than or equal to 8p, which makes p smaller than or equal to 2. So for any value of p smaller than 2, our original equation is going to have roots. Otherwise, if it is not, it's going to have non-real roots. I want to add something on here. If I had left this minus 8p on the side, and I was saying that it must be bigger than or equal to negative 16, I'm now going to divide by negative 8. And if I divide by a negative across an inequality, it will reverse direction. So p must be smaller than or equal to 2. So whether I use it in this format, I'm still getting p smaller than 2. P is smaller than 2. I read it in the way that I'm following. So p is smaller than 2. P is smaller than 2. Both of these say exactly the same thing. Okay, just in case you were wondering. I avoided this one because I didn't want to get into the negatives and reverse the direction, but some of you may have used it in this way. Not a problem. If you're dividing by a negative, that inequality will reverse direction.
All right, Dina, I think the mindsetters might have picked an error.
Yes.
Whereby you said the answer was 981 minus 80.
Yes.
They said that your answer should be 1, not 9.
Oh, yes. There we go. Thank you, mindsetters. Oh, I give you 12 out of 10, mindsetters. That's great.
Well done.
Awesome. So that would be equal to 1. And it's still, the beauty of it is it was a good mistake because 1 is still positive and 1 is still a perfect square, so the roots will still be rational and equal. It doesn't change the nature, but 81 minus 80, yeah, definitely is 1. Thank you for that.
All right, Dina, can you link us to a net break?
Yes,
Please.
let's go.
Tell the mindsetters that are going to the air break. Welcome back, Mindsetters. It is still our Triple M day, which is Mindsetters Maths Monday. Hope you've enjoyed that trailer. Now, that trailer, it is following a movie that's coming soon on the 7th of June, as you've seen, starring by Will Smith and his son, Jaden Smith. And now, if you'd like to win some tickets, double tickets for you and your friend to come watch this movie, all you need to do it is go over Facebook and get more details on how you can enter for this competition. But the link for the entry is simply learnextra.co.za/After Earth. That is what the movie is all about. I'll be announcing also some of the winners that have won for this competition, such as the winner that entered last week, Thursday, Mpumelelo Ngema. Congratulations to you. You've won yourself double tickets to watch After Earth. And also another winner that we have is Rofiwa Nemutanzela. Well done to you too. And the last winner that we have, it is Baleni Ngubego. Well done to you too. And now, if you'd like to win for today's show, the keyword for you grade 11s, it is biodiversity. I'll post that link or that code to our Facebook page, which is facebook.com/learnextra. Remember, the keyword that you need to enter for the competition is biodiversity. Let's get rocking and let's win more on our Facebook page, After Earth competition. It is such a great movie. I can't wait to see it on the 7th of June. It's coming soon. Mindsetters, make sure that you enter now. learnextra.co.za/After Earth. Dina, let's continue.
Thank you. That's great. I hope that you all got that biodiversity. Get in. Yeah, you can win. Right, let's get back to the maths. We are looking at exponents now, and I'm going to divide it into two sections, looking at expressions and looking at equations. Why would that surprise you? That's what we're doing in maths all the time. We always look at an expression. We always look at how that expression can be utilized in an equation. So exponents is no different. So let's go right to it. We've got simplifying of expressions. And guess what? I am not going to do those easy, simple ones that your teachers gave you to do. I'm going to do the most difficult things, the things that you need to spot in the exams, because that's the things that are going to be in the exams. So we're going to look at When I say the most difficult, it's not really that difficult. But it's something that requires you to think about the structure of the question. If you can think about its structure, you won't land up in the mess that so many people land up because they're not using the right rules. I'm not going to familiarize yourself with the rules. I'm expecting you to know those. You've done them from primary school right through to grade 10. So the rules about powers and when the base is the same and we add the exponents and all that kind of thing, I'm expecting you to know it. I really want to challenge you. I want to take you to a new level, a level where you begin to think about the structure of that expression. So let's get right to it. The first one, and you can get it on the page, and I've divided it into two sections. I'm going to do the yellow question, and then I'm going to do the green question. Something interesting that you find in both questions. What do you spot that's the same? They're both fractions. That's the first point that you get. Second point is that they've both got terms in the numerator and denominator. So the moment there's terms, these things belong either in the numerator or denominator. That's why they look the way they are. However, when we do maths, I'm not sure who decided on this, but they should have never written it vertically, because when they write it vertically, we get it all wrong. They should have actually written it horizontally. This really means that it's an A. It's an A to the minus 2 minus a B to the minus 2. And then I want to divide it by A to the minus 1 plus B to the minus 1. Now, do you think that that's what that means if I had to write it horizontally? Definitely not. I want to get this answer, and once I've got that answer in my numerator, I want to divide it by the denominator, so it needs a bracket. And grade 11s and everybody else watching, if you don't have those brackets around those numerators and denominators, they do not mean the same thing. Now, I can guarantee you, if in South Africa we all had to write that vertical division in a horizontal fashion, you would find so many of you not landing up into the temptations that this question draws you into. The first one is that you will just divide A by A because you see a division sign. But this question does not ask you to do that. Remember the structure of the question. It has a division sign here. And this division sign means that there's going to be an order of operations. And the order is when I do it in the horizontal, you're going to have the numerator's answer and you're going to have the denominator's answer. If you had to write it in this way, you would not be dividing that A by A. I know that. And so I think we should change the textbooks in South Africa, and we should all write it horizontally. Then we wouldn't make these horrible mistakes that you often do. So I'm going to suggest that when there are terms, that you first write it, even if you're doing trig as well, that you first write it in a horizontal way. Now you are going to ask yourself, well, what must I do with A to the minus 2? What can I do with that? Well, I can certainly rewrite it. I know what that means. That means 1 over A squared. Because every negative exponent means the reciprocal of the base. And then I've got minus 1 over B squared. Every negative exponent, say it to yourself, is the reciprocal of the base. And then I'm going to divide it by 1 over A plus 1 over B. Every negative exponent is the reciprocal of the base. Negative exponent, reciprocal of the base. So I keep going. I've now landed, all of a sudden, with two fractions. Common denominator, and reorganize your numerators as B squared minus A squared. And I'm going to divide that by B plus A. Okay. So now I'm sitting with a fraction or an expression in fractional form that I can actually see the difference of squares. So I can factorize that. And I can, in my division is the same as what? Multiplication of the reciprocal. So B plus A. And now that I've got just factors, it's that times that times that, divided by that times that. Division and multiplication I can now do as one. I'm not going to divide illegally like some of you do. That goes in there, so I'm left with B minus A. And the A goes in here, so I'm left with an A. And the B goes in there, so that's a B. So what I really want to really hone in on is that when you have terms, you cannot divide because they actually belong together. You can only divide when you have one term. So division of fractions can only happen. Okay? And look at it for yourself and analyze the structure of the expression. Division of fractions can only happen if I have only only when we have one term divided by one term. So when we first look at the numerator, we say, hello, are you one term? Look at the denominator. Hello, are you one term? If we have one term, we can divide. If we don't, then we need to go and add it together or expand it or do something with it to get it into one term. Okay. And then the green one, exactly what I've just been saying, if we had to write it horizontally, we would not land up in dividing the 5x by 5x, because most of you will look at that and say, oh, lovely, 5, I can go into 5, and x can go into x. We cannot do exponential expressions like that, because when we look at it, it's actually got minus 4 times. So there are 2 terms. Over here, there are 2 terms. 2 terms divided by 2 terms, I cannot divide. I need to get it to 1 term. What is the maths process that gets you from 2 to 1? It's that beautiful process called factorization that you first met in grade 9 and you have fallen in love with and you've never given up on it. Because factorizing is just going to be your buddy for life. You cannot ignore factorizing. It's going to help you out of all the division questions that you have and much more. So we now have a situation where we'd like to factorize this. So we would like to say what is common in both. But we now notice there's an exponential expression of 5 to the x plus 2. First thing we're going to do is let's expand it into its constituent powers. Are you happy that 5 to the x plus 2 is just 5 to the x times 5 squared? So the sum of 2 exponents means that they come from the same base. It's the product of 2 powers with the same base. Minus 4 times 5 to the x divided by 5 to the x times 5 to the negative 1 plus 2 times 5 to the x times 5. And then we're still looking for that one term, so we still want one term. So we want to find a common factor. There's my 5x and there's my 5x. Only when the base and the exponent are exactly the same can we take them out. So that's common. Here in the denominator, we have another one, and there's another one in this term. And what does taking out a common factor mean? So when you're taking out a factor, what do you say to yourself? What does it actually mean? What are you doing? You're dividing. So we're now going to divide. We're going to take it out means we're going to divide. So when we divide that by that, we get 25. When we divide that by 5 to the x, we get a 4. When we divide by 5 to the x, we get a 5th, and when we add 2 5s, we're adding 10. So we land up with, do we have one term? Yes, because we've got something times bracket, something times bracket. It doesn't matter what's inside the bracket. Inside the bracket, there are 2 terms, that's fine, but it's still one complex term. So we can have 5abc, which is a simple term because it's 5 times a times b times c, or we can have 5 times bracket times bracket times bracket. Those brackets are still seen as one factor, and that's called a complex term. So now we can divide 5 into the x into 5 to the x, and we're left with 21, and we're going to divide that by, that would be 51 over 5, so it's 51 over 5. So it's 21 times 5 over 51. And I think that's how we're going to leave that, so we can get onto the equations. But I really want to re-emphasize why I'm doing these questions. I'm doing them because both these questions contain more than one term in the numerator. More than one term in the numerator and denominator. So in each one of those, in this one we didn't really factorize, but in this exponential expression we did, we would always get it to one term. And to get it to one term means to factorize. Because this expression here had negative exponents, we first undid the negative exponents in order to see where we were going with it. So this was a lot more complicated, and it's I think the reason it's complicated is you don't read, you don't see the meaning of the structure. So try and always probe why is this given? What can I do with it? So that you can not fall into the trap that so many people fall into, which is just they see same base, same exponent, and they just divide crazily, which is very, very wrong. Okay, so let's go on to the equations. There we go. We're going to solve for x in these two. And again, we see that there are terms, and again, our buddy factorizing is going to help us to get things to one term. A slightly different thing when we get to exponential equations, and that is that we'd like to get to both sides of the equation with the same base and same exponent. So, for example, in 2 to the x minus 2 to the x minus 2 equals 12, I can see that these two terms have got a common factor. So let's just go from here and say that I could actually rewrite this as 2 to the x times 2 to the negative 2. Remember, I'm undoing my exponential law of the same base, and that's equal to 12. Now, because I've got this common factor of this unknown, so the unknown can actually be factorized, what does it mean to take out a factor? Means to divide each term by that. So divide that by that, what do you get? 1. Divide that term by 2 to the x, what do we get? A quarter. And that's now equal to 12. Okay. And grade 11s, you must check your work. So if you times 2 to the x by 1, you're going to get back there. If you times 2 to the x by the quarter, you're going to get back there. So make sure you can actually check your work. You don't have to give it to a teacher to mark it. You can test your own work and be happy with the accuracy of your own work. So I can actually check that. So I then get 2 to the x is equal to, what am I getting inside here? I'm getting 3/4, right? So I'm going to divide that by 3/4, which means times by 4 over 3. So I get 2 to the x is equal to 16, which is 2 to the 4. Can you see how we want to get to a situation with an exponential equation that we want the same base on both sides? Same base on both sides. In that way, when the bases are the same, then we are saying automatically, this makes sense, that my exponent must also be the same. Now, some of you are very clever and you're already asking, what about if I've got 2 to the x equals 17? So 17 can't be written as a power of 2. Well, you'll have to wait for your grade 12 lesson, or wait till next year when we talk about logarithms. And logarithms are going to be able to help us there. So grade 11s for now, you should only be getting equations where the exponent is, or the power is a power of that base that's given with the unknown. If not, then you could make a guess. I mean, if you got 17, we know that it's very close to 16, so it must be 4 common something. So you could have a conjecture, and a conjecture is an intellectual guess. It's a guess based on estimation. So you could do that. But for now, we would only do that. Next year, we will use logarithms. You will have, on your calculators, you'll see that log button. That will help us when we can't get it into a power of the given unknown. Okay, and then, lastly, what about if we have rational exponents? What do we do with something like x to the 2 over 3 minus 3x to the 3rd minus 10? Anyone worked with those before? Okay, so we've got, let's just rewrite it here. So we've got 2x to the 2/3. No, actually it's not 2. Let's not work with 2. It's just x to the 2/3 minus 3x to the 3rd minus 10 equals 0. Let's make sure our coefficients are right as per the question. Minus 3x to the 3rd. Yes. Okay. All right. Now, if I had to write this as x to the 3rd and then square it, minus 3x to the 3rd minus 10, can you see that if I let your x to the 3rd be represented by k, for example, then I've got k squared minus 3k minus 10 equals 0. Ah, I like that because I can factorize that quadratic. I can have k minus 5, k plus 2 is equal to 0. Minus 5 plus 2 is negative 3. Negative 5 times 2 is negative 10. So therefore, k equals 5, or k is equal to minus 2. So in the end, what we're really saying by using what we originally had, because we're not solving for k, we're solving for x, we can then say that x to the third should now be equal to 5, or x to the third is equal to negative 2. And how are we going to undo this third? What do we have to do to both sides? Grade 11s, what do you think we should do? We must cube both sides. In that way, this 3 goes into that 3, so we're left with x equals 125. Or I'm also going to cube this side, so I'm going to get x equals negative 8. So I get two solutions. It actually turns out to be a quadratic with two solutions of 125 and negative 8. And so that's it, grade 11s. Thank you for being with us.
Thank you so much, Dina. And I just want to say this to all the mindsetters. If you're still having some questions, I can see some of the mindsetters are still confused on the page. Let's help one another and also make sure that you have your own notes. But from today, for today's show, I just want to say thank you very much for being with us. And also on the page, we love you lots. And a big thank you to our sponsor, which is Macmillan, for making sure that we do have these notes. And they're available to you too. So thank you. Check you out some other time.
Before we actually get there, I would like to look at what is the quadratic formula. It will be in your formula sheet, but just to remind everybody, the quadratic formula is, for a quadratic equation, is minus b plus or minus the square root of b squared minus 4ac, and we're dividing everything by 2a. So if we're solving a quadratic equation, we would like to use the formula if the factors aren't readily available. Okay. Now, I've grouped these together so we can start discussing some of the trends that we see. So the first thing that you need to look at is always to read the instruction. It says solve for x. And the first one is where x squared is equal to x. Second one, where x squared is smaller than x, where x squared is bigger than x, and then 3 times the bracket is equal to negative 7x. Now, when we look at the grouping, I would really like to concentrate on how we would solve these three, because they really are together. We're going to really try and dig and probe into what method of solution we're going to employ and also how we would go about it. Now, grade 11s, I find that when the equation
of this family and let the family grow, tell other people so that they could also tell other people. We are running also competition on our Facebook page whereby you can just guess when do you think we can hit 42,000. If you know the answer, you're good at guessing, go over our Facebook page. And number 2, you can also tweet us at LearnExtra. And lastly, this show is proudly sponsored by Macmillan, and the notes that you can download today for free can be accessible on learnextra.co.za/live, or the link, I'll make sure that it's posted on our Facebook page. But for now, let the learning roll. Dina, take it away.
Thanks very much, Abraham. Grade 11s, are you ready to see how much you can remember? Because if you can remember all of today's work, then you are certainly ready for your June examination and maybe even for that final examination in November. So let's get right to it. The topics for today, we're going to look at some equations, some inequalities, and both those in the quadratic field. We're going to look at the nature of roots, and we're also going to look at some work around exponents. We're going to revise those 4 topics by working through some worked examples. And the first section will be quadratic equations and inequalities. We're going to solve for x in each one of these and give us 1. And so I want to look at 2 things. What kind of quadratics will give us 1 solution? So that if we know what that model looks like, we can try and see if we can apply it to this case also. And the kind of quadratics, we're going to pause here, we're going to camp here for a little while, just pause there. We're going to say, what kind of quadratic equations have one solution? With one solution. And you may also ask, well, what kind of quadratic equations have no solutions? Okay? So quadratic equations with one solution is anything that has got a bracket squared. So if you had x minus 1 squared, for example, then x could only be 1, because 1 minus 1 is 0. Or you could get an x squared equals 0, for example. So any quadratic equation, when it's equated to 0 in its squared form, its perfect square is going to give us only one solution. Now, if you compare that to this one, x squared is equal to x is not equal to 0 at this stage. So we don't have a perfect square. So I'm, at this stage, arguing that
Hello, grade 11s. It's still our Triple M day, which is Mindset is Maths Monday. Hope you're all relaxed and ready to learn a lot. My name is Abraham, and I'm not alone. I'm with Dina. How are you, Dina?
Hello, Abraham. I'm very, very well. And how's everybody out there?
They are pashash. They are number one, I'm sure, because they couldn't wait for this show. I've been seeing on our Facebook page saying, you know what, let's go. Grade 11s, we're up and ready. But for today, what are we doing?
Abraham, today we are going to look at some of the work that we've already covered in term 1. So we're doing some revision. We're looking at some equations, some inequalities, and some nature of roots. So we're going to do a couple of examples to see how much you can remember from term 1.
Jam-packed show, I tell you right now. Let's get ready. Dina, take your position.
Thank you.
Right, Mindset is talking about being ready. It is our Triple M day, which is Mindset is Maths Monday. And also, there are 3 things that you need to know. One is that you can chat with me over Facebook. Send us your comments and also your questions. Our Facebook link is facebook.com/learnextra. Get your friends also to like the page, because currently we are at 41,000 and more. If you still want to be part
Equation x squared is equal to x. Very simply written, it's an x to the power of 2, x to the power of 1. And a number of students, even at grade 10 level, because you really start with quadratics at grade 10, will say, well, if I've got x squared is equal to x, then I can divide by x on both sides. So I'm getting that x must be equal to 1. Okay, now if we go back to the original, we then find that if x is 1, it makes that a true statement. But when you're solving an equation, you want to make sure that you have found all the possible values of x that that equation could have, so that that statement is true. So you're trying to find every single one. Now you found one value, and the interesting thing about a quadratic equation is that the highest power tells you what the possible number of solutions are. So if you've got the highest power as 2, you should be able to have a maximum of 2 solutions. We've only got 1. Now that is not cause for concern, because sometimes quadratic equations do only have 1. But we must be certain that we have the conditions, the right conditions, to be able to get